Okay, so we have solving quadratic equations. If you were not here yesterday, all of this is just reviewing from grade 10. Two ways to solve an equation. First, put the equation in standard form, and remember that one side has to be equal to 0. And then once you have that, the two strategies you would use to solve this equation would be factoring. Okay, you do factoring if it's possible. But when you cannot factor, the other strategy would be to use the quadratic formula. Okay. And the quadratic formula is this: x equals negative b plus or minus the square root of b squared minus 4 times a times c, all within that square root sign. And then everything is divided by 2a, where a, b, and c all come from the quadratic equation. Okay, so you'd always use option 1. You should always be factoring. If the expression is factorable, usually it's faster. Otherwise, you can use the quadratic formula. The quadratic formula should work in all cases. Okay, so I went through some examples. So here's just 3 examples for this lesson. All of these are word problems, and I go through how to solve each of these quadratic equations. So example 1, Anthony owns a business that sells parts for electronic game systems. So electronic game systems like PlayStation or Xbox or computer, we're selling parts here. So the profit function for his business can be modeled by the equation P, capital P. And here it is, negative 0.5x squared plus 8x minus 24. So profit means revenue minus costs. So whatever money you make above what it costs you to sell or to make those parts or buy those parts that you're selling. Okay, and so in this equation, x is the quantity sold in thousands. So if x was like the number 5, for example, then the 5 represents 5,000 parts being sold. And so is the profit. So whatever profit you're calculating, if the number was 19, then the profit is $19,000. Okay, so it's always numbers in thousands. How many parts must Anthony sell in order for his business to break even? And I also went over this term. Break even means when your profit is equal to 0. Okay, so if your profit is equal to revenue minus costs, then to get 0 profit means your revenue has to equal your costs. So all the revenue means all the money you earn is equal to all the costs, the money that you have to pay to either make, manufacture, or buy your product that you're trying to sell. So profit equals 0. So that's the key thing when you see these words break even. And that break even is very common to see in your study economics or accounting. Okay, so let's look at that. Profit is equal to 0. The equation is negative 0.5x squared plus 8x minus 24, and now I'm solving for x. So what value of x gives me a profit of 0? So your strategies again are factoring or quadratic formula. So you try and factor first. Okay, so factoring this means, well, I'm looking for a common factor. I have a decimal here, and so I only have one decimal here in front of x squared. So I'm going to try and factor out that decimal. Okay, it's a decimal is okay to work with, is 0.5 because it doesn't really change my integers. So negative 0.5 comes out, x squared. And when I say it doesn't change my integers, I mean it doesn't change the integers into a decimal. I can keep these other terms as integers. So 8 divided by negative 0.5 is minus 16x, and minus 24 divided by negative 0.5 is positive 48. So I still have a trinomial in here in this bracket, x squared minus 16x plus 48. You think, you keep going, can you factor this? Simple trinomial factoring, product sum, 2 numbers that multiply to give you 48 and add up to negative 16. Those 2 numbers are 12 and 4. So x minus 12 and x minus 4 are my factors. Okay. And remember, this is equal to 0, so solving for x means solve for each x in each individual factor. Okay, it doesn't matter that this is negative 0.5. All I care about is x minus 12. That's equal to 0. So x has to equal positive 12. And the other factor is x minus 4 equal to 0. So x has to equal positive 4. So those are my two solutions. So we call these solutions. Now I don't need the bigger number. I only need the smaller number, because when you're selling parts, you start from 0 parts and you work your way up. So the moment I reach 4,000 parts, then Anthony will break even. He'll have 0 profit. So Anthony must sell 4,000 parts to break even. Okay, if he sells less than 4,000, if he sells 3,900, he's not going to break even. It costs more to run the business than it is to make money. So if at 4,000, he breaks even, and above 4,000, he starts to make profit. Okay, so that was the first example. Example number 2. Water balloon is catapulted into the air from the top of a building. So I'll draw a building. Here's my building. Someone is going to build a catapult at the top of the building, put a water balloon, and it's going to be launched from the top of the building. Okay, and the launch of a catapult or any projectile through the air follows a parabolic path, and so that equation for that path is given to you by this function h of t. So h of t, h is my height. So think of h as my height. T is my x-axis. Good morning. Thank you. And so the rest of this goes like this. So A is, what is my domain and range? And for quadratics, usually the domain is every real number. However, here's a word problem. So here in our word problem, the domain will be slightly different. So we start with t, because t is my independent variable. So t is every real number. And t represents time after t seconds. And so with time, we don't usually have negative values, so I'll start at 0. So 0 less than or equal to t. And now where is t going to end? Well, t ends whenever the ball hits the ground, or the balloon hits the ground. It doesn't go after that. It doesn't go into the ground. It's the ground and it stops. So the question becomes, when does the ball hit the ground? So when does the balloon hit the ground? Okay, so at the ground, my height, h of t, is 0. So I'm going to use my equation and say 0 equals negative 5t squared plus 30t plus 10. And I'm going to solve for t. Okay, and this time I'm going to use the quadratic formula to solve for t. I can't factor this, so I have to use the quadratic formula. So I'm going to say my quadratic formula. Well, let's get my a, b, and c values. So a is going to be negative 5, b will be 30, and c will be positive 10. Just reading it from my equation. Okay, and then if I take the quadratic formula, t equals, substitute your values into your quadratic formula. Negative b, so negative 30, plus or minus the square root of b squared, so 30 squared, minus 4 times a is negative 5, times c, which is 10, divided by 2 times a, so 2 times negative 5. Simplifying this, we get negative 30 plus or minus the square root of 30 squared is 30 times 30, which is 900. 4 times 5 is 20, times 10 is 200. So 900 plus 200 is 1100, all over negative 10. And I can simplify that even a little bit further. That would be negative 30. I'll go into decimals now. So the square root of 1100 is 33.17 over negative 10. And I get two results from that. Negative 30 plus 33 over negative 10, which gives you negative 0.317. And negative 30 minus 33 over negative 10, which gives you 6.32. Okay. So the negative answer I'm not going to keep. We don't have negative time. So I'll keep the 6.32. And so that's 6.32 seconds where the balloon hits the ground. So that will help me complete my domain. So 6.32 is the value I'll put here in my domain. I'm highlighting it there to show you that I calculated that value. For my range, height is my dependent variable. Height is every real number. So for my range, 0 is my lowest value for my height. I can't go negatives either. So 0 is my lowest point. The highest point is the maximum value. So somewhere in my picture here, I'm going to point out that there's a maximum value. Okay. Where does the balloon start? Well, according to my equation, the C value is my y-intercept. So that's at 10 meters. So my maximum value has to be higher than 10. Okay, so you have to remember, how do I find my maximum value? I'm going to start with my axis of symmetry. So I need my axis of symmetry to get the x-coordinate of my vertex. Remember, this is the vertex. So the vertex represents my maximum point. Okay, to get my vertex, I need the axis of symmetry. So I start with that. Negative b over 2a. And that's equal to, plug in your b value, negative 30 over 2 times a, which is negative 5. 30 over 2 times 5 is negative 30 over negative 10. And negative 30 over negative 10 is positive 3. Okay, and so after you get the axis of symmetry, substitute it into your equation to find the maximum height. So the height at t equals 3 will be negative 5 times 3 squared plus 30 times 3 plus 10, and that's going to equal 55. So 55 is my maximum height. I put that into my range, and that completes my domain and range. So that's part A. Part B, when will the balloon reach a height of 30 meters? Okay, so I had room yesterday here on this page. I think I wrote a little bit too big. So I'm going to just go into my void blank space here. So here I have height. When is the height? When is h of t equal to 30 meters? That's the question. So into my equation, I'm going to put h equals 30, and then write out the rest of my equation on the right side, negative 5t squared plus 30t plus 10. So the question is, what is t when h equals 30? So I have a new equation to solve. So this equation here, just the only difference now is h is 30 instead of 0. Okay, but solving an equation still requires us to make one side equal to 0. So to make this left side equal to 0, I have to subtract 30 from both sides. So I'll do 0 equals negative 5t squared plus 30t plus 10 minus 30. And if you simplify that, you get 0 equals negative 5t squared plus 30t minus 20. So this is the equation that I have to solve. It's equal to 0. The only difference is this last term isn't 10 anymore, it's just minus 20. Okay, so I'm going to use the quadratic formula again to solve for t. So solve for t here. Let's say solve for t. And so t equals, can we factor it? We can factor out, yeah, you could factor out -5, sure. But you couldn't factor the simple trinomial inside. So t squared minus 6t plus 4. Simple trinomial, you can't use product sum. Okay, so that's not factorable. So I'll use the quadratic formula. My values for a and b and c that I'll use are -5, 30, and -20. Okay. So if I plug that into my quadratic formula, t equals -b, so negative of 30, plus or minus the square root of 30 squared, minus 4 times a, which is -5, times c, which is -20, over 2 times -5. Okay. Now this one I'm going to solve just using exact values. Okay, so -30 plus or minus 30 squared is 900. Minus 4 times 5 is 20. Times 20 is 400. So I have how many negatives here? I have negative, negative, negative. So multiplying those out makes it minus, and minus 400. Okay. Divided by 2 times -5, which is -10. And -30 plus or minus the square root of 900 minus 400 is -30 plus or minus the square root of 500 over -10. Okay. And that now that we've learned in the last chapter how to simplify radicals, you shouldn't really need to go to the calculator too much. You can simplify square root of 500 as so -30 plus or minus the square root of 100 times the square root of 5. And that's over -10. And now I can simplify that. -30 over -10 is +3, plus or minus square root of 100 is 10, and 10 over 10 is just 1, and then I have the square root of 5. So 3 plus or minus the square root of 5. Now I know that there's a -10 on the bottom, and when I do 10 over -10, that's supposed to be -1. But because I'm doing both plus and minus already, I'm just ignoring it. I'm just saying plus or minus square root of 5. And so that's your value for t. So t, when t equals 3 plus or minus the square root of 5, the height of the balloon is 30 meters. Okay, so two values of t where the height of the balloon is 30 meters. If you converted this to decimals, you would get 5.236 seconds and 0.7639 seconds. I prefer the exact value. If you're checking your answer at the back of the book, sometimes you might need to convert to decimals. And for most word problems, usually it's okay to convert to decimals. Okay, the last example, the factory example. Where was I here? Over here. Okay. So a factory is to be built on a lot that measures 80 by 60. So first sentence says, draw a lot, 80 by 60. So 80 this way, 80 meters and 60 meters wide. Okay. A lawn is going to be drawn inside the factory lot. Just going to draw my own rectangle. Okay, there we go. So there's my lawn. My lawn is going to be this part here. Make some nice grass. Okay. And the width of that lawn, it has to have a width, so I'm going to give it a width of x. It's uniform. The word uniform means the same width all around. Okay, so x all around, like that. And so my factory, well, my factory can no longer be 80 meters long. It has to be 80 minus 2x. So that's the length of my factory. And the width of my factory has to be 60 minus 2x. So that's the width. Okay, so I keep reading the question. So how wide is the strip of lawn and what are the dimensions of the factory? And so the only other thing we're told is that the lawn is of uniform width is equal to the area of the factory. So the area of the lawn must be equal to the area of the factory. So I'll start off with that statement. So the area of my factory is equal to the area of the lawn. Okay. And we know the area of the factory now is 80 minus 2x times 60 minus 2x. However, I don't know the area of the lawn. Okay. But being told that the area of the factory has to equal to the area of the lawn, I can sort of infer that the area of the lawn must be half of the area of the entire lot. And the entire lot is 80 meters times 60 meters. Okay, and so 80 times 60 is 4,800. 4,800 divided by 2 is 2,400. So the area of my factory has to be 2,400, which is equal to the area of the lawn, which is 2,400, for a total area of 4,800. Okay, this is the only number that can make it so that the area of the factory equals the area of the lawn. And you're using up the entire lot. Okay, so that is the number we're going to use. So that helps us create our equation. And this is the equation. We have something on the left, something on the right, set equal to each other. So we're going to solve for x. And to do that, I have to expand and collect like terms. Okay, so I'm going to expand the left side. 80 times 60 is 4,800. 80 times 2 is minus 160x. Minus 2x times 60 is minus 120x. Minus 2x times minus 2x is plus 4x squared. That's equal to 2,400. It's going to collect like terms, reorder them as well. So I'll put 4x squared in the beginning. Minus 60 minus 120 is minus 280x. And then if I subtract 2,400 from both sides, I'll have plus 2,400 on the left equal to 0. Okay, so now I have a quadratic equation in standard form equal to 0. I'm going to try and factor this first. So if I factor out a common factor of 4, 4 comes out. I have x squared. 280 divided by 4 is 70, so minus 70x. And 2,400 divided by 4 is 600. And that's equal to 0. And the inside of my bracket, x squared minus 70x plus 600, I can factor that as well. Two numbers that multiply to 600 and add up to 70 would be negative 60 and negative 10. So 4 times x minus 60 and x minus 10. Even with large numbers, you just have to think about what are the easy ways to get to 600 and find those two numbers, 60 and 10 being an obvious choice, and check to see if they add up to the middle number, 70, and they do. Okay, and so that's equal to 0. Solving for x, in one bracket I get x equals 60, and in the other bracket I get x equals 10. okay? However, x equals 60 is too big, okay? If I use x equals 60, my ln is wider than the actual lot dimensions that I'm given. Okay, so if I put 60 where I have these x's here, and I only have 60 meters for the width of my lot, then I couldn't fit 2x. It wouldn't be possible. So I can't use x equals 60 for my ln. So I'm going to take that as discount that as one of my answers. So the actual answer is x equals 10. So here, therefore, the width of my ln, so width of the ln is 10 meters. And the dimensions of my factory, so again, the word dimensions means what are my length and width of my factory, are, so my length is 80 minus 2x, so 80 minus 2x, which is equal to 80 minus 2 times 10, which is 60 meters. And the width of my factory is 60 minus 2x, which is equal to 60 minus 2 times 10, and that's 40 meters. Okay. And so again, if you use 60 meters in this equation, you'd get negative values for your length and width for your factory, so that's not possible. Okay, that is 3 examples on solving quadratic equation word problems.